All right, so yesterday we derived inverse trig derivatives. And remember, we only focused on arcsine and arctan. What we're doing now is just everything backwards. And it lines up really well. If you know one formula, it helps you know the other one. All right, they're not exactly the same. Now remember, for arcsine, it was really u prime over square root of 1 minus u squared. Okay, do you see the big difference here? It's not 1, it's a squared. So I can already look at example 1 down here and I can see that, hey, that's not 1 minus x squared, it's 4 minus x squared. So that's something we're going to have to deal with. But again, it's really just, do you know this formula? You need to practice it. This is why I've given you flashcards. You really need to cut them up and practice drilling them with them, okay? So, for arctan, remember it was u prime over 1 plus u squared. So again, we have du, but instead of 1, we have an a squared. And then what's the difference in this formula? What's the difference? It's a 1 over a. You got to remember to do that when you're dealing with arctan. Okay, so pretty much what we're going to be doing here is we're looking at this problem, and now in the future you're going to have to decide, hey, this is an inverse trig problem. The way you're going to do that is if there's just a number here on top or a derivative of your u or something like that, because we did problems like this before. Okay, I don't want you to write this down, but I want you to follow me here for just a second. If I gave this problem to you like a week ago, this is how you would have done it. You would have let u be that thing underneath the radical, right? That's how we did these. But then du would be negative 2x dx. The negative 2 is fine, but this x right here is nowhere in the problem. We got a dx, but that x is not there. So do you see how this is, we couldn't have done this problem before with normal U-substitution. If there was an x on top, we could have, but not the way it is. So that's kind of your clue that we're going to have to use inverse trig. So really what we need to do is first identify the a. Once you're like, I think this is an inverse trig problem, okay, well, listen. So what's a? If the formula is a squared minus u squared, a is 2. And a is always a number. A is always a number. U could be x, a number x, sine x, e to the x, but a is always a number. Okay, now I'm going to have to go back on something that I said to y'all before. I said to y'all before, don't ever let u be just x. This is the one exception. The reason, it's not that u equal x was bad, it just never helped you because it was just trade one letter for another. Here it is going to help us because it's going to help us use this formula. So then what would du equal? What's the derivative of x? Dx, or 1 dx, right? Okay, so look what happens. We take out the dx, and in its place, we write du. Down here I have a square root. We take out the 4, we write in a squared, since a is 2. Minus, instead of x squared, we're going to write u squared. And that is this formula up here for arcsine. That's just more or less a confirmation of that. So if I know I'm using arcsine, let's go ahead and write arcsine. And then this says u over a. So again, if you've written all this up here, it's nice. You go x over 2 plus c. And that's it. These problems are actually, for the most part, easier than what we had been doing, I think, if you know the formula. If you don't know the formula, then it's not easy. Okay, let's look at the next one.
Will the x ever... Oh, never mind.
It could be something other than...
It happened, so...
Yes, it is about to happen. I am psychic and I know exactly what you're asking or thinking. Maybe. I don't know. Okay, first of all, I want you to notice, see how this dx was on top? This dx is over here. Those are the same. Don't let that throw you. On top of the fraction, off to the side of the fraction, those two things mean the same. All right, now again, I know this is a inverse trig problem because if I let u be the denominator, I'm going to have something in my du statement that's not in the problem. Okay, so this is my clue. Hey, let's use inverse trig. So then A, what's A? It's not 2. It's square root of 2. Remember, this thing is really a squared, so A is square root of 2. That's going to happen from time to time. Okay? When your A squared is not a perfect square, you're still just square rooting. All right. U then is going to equal, okay, this is kind of, I think, what you were thinking of earlier. What's U? So remember, it's U squared. So what's being squared there? 3x, right? So U is 3x. What's du?
1/3.
Well, 3 dx, right? And then we move the 3 over to make 1/3. Just like how we did the other problems. Just take the derivative of 3x. It's 3 dx. And then we divide that 1/3 over. And that thing is just going to go in the front of the integral symbol, okay? Just going to get multiplied to everything else. This 1 in dx, that gets replaced with du. This 2 gets replaced with a squared. This 9x squared, or 3x in parentheses squared, gets replaced with u squared, which is this formula right here. It's more of just a confirmation. Some of you are real quick not going to need to actually write this step. You're going to know that it's working out, and you're going to go straight to the arctan. Just putting that out there. It kind of just depends on how you think about it. So this is going to be, I didn't mean to go that far. This is going to be 1/3, and then remember, don't forget about this 1 over a. We got to multiply by 1 over root 2. Don't worry about simplifying or that there's a radical in the denominator. It's no big deal. Arctan, I'm just following this formula, u over a. So 3x over root 2. And then, of course, plus c. So if you know the formula, this is less work than what we had been doing. All right, now how would we normally check our integral answers? Take the derivative. That's actually not going to work on most of these. Yay. The reason is because a is something other than 1. These are not going to work out really nice. Because think about how we would take this derivative. I would have to take the derivative of this, put it on top, and then down at the bottom I would have square root of 1 minus something. It wouldn't look like this. It would be equivalent, but it wouldn't look like it. Okay? So just know that. Another reason for you to really be comfortable with the formulas. Okay, I want you on your own to go ahead and figure out what is a, what is u, and what is du. Okay, so what is a in this problem? Square root of 1, which is just 1. So since a is 1, this is going to be one I can check with the derivative, by the way. What did you guys get for u? E to the x. Okay, because e to the 2x is the same as e to the x squared. All right, then du, what's the derivative of e to the x? E to the x, dx, which is all right here. So when I rewrite this, e to the x dx gets replaced with du. Down here, this square root gets replaced with a squared minus u squared, which is arc sine u over a. So e to the x over 1. Do you have to write the plus 1? Of course not. And that's it. If you feel like you could go straight from here to here, that's fine. That's going to happen to most of you after you practice this a little bit. You're going to take, that's not a necessary step because I already know it works out. Okay, let's look at the next problem. How is this one different than what we had been doing? It has two things on top. So I want to show you something here. If I were to just say, oh, this thing doesn't have a +2. This is actually a regular U-substitution problem. Okay, and we're going to work that part out in just a minute. And if I were to erase or scratch out the x, this would be an arc sine problem. So if it's easier to deal with these things one at a time, that's what we're going to do. We're going to split it up into x over square root of 9 minus x squared dx. And I'm like really splitting these up, like into two totally separate integrals. And we're just going to solve these two integrals, and at the end, we're going to put our answers together. Okay? And I'm going to even do them in two different colors so that's more obvious. So I had already kind of told you guys this was a normal U-substitution. The way you're going to know this in the future is because there's an x in the numerator. So what are we going to let u equal?
X squared.
So think about how we did U-substitution. If we saw a radical, if we saw a radical, we let u be that thing in the radical. So then du would be negative 2x dx. We divide over that negative 2, and so the negative 1/2 would go in front. And if you notice, this x dx is right here. That's why this works out. And so what is the power on u if it's in the denominator and under a radical? Both. Negative 1/2. Negative because of the denominator, 1/2 because of the square root. So negative 1/2. So I'm going to follow this one all the way through, and then we'll deal with the other one. Okay, leave a space, write your u. What's going to be the new power on u? What do we add? We add 1. Negative 1/2 plus 1 is 1/2, and write the reciprocal in front. You can write a little plus c there if you want. That cancels. If you didn't notice that, that's okay. You don't have to simplify. So if this was my only problem, I would be done. But it's not. It's half of it, though. Okay, let's look at this other one over here. First of all, this 2, let's just move the 2 out to the front and really pretend that like there's a 1 on top. Because we can do that. We can move numbers out to the front. Okay, because there's a 1 on top now, this is what's giving me my clue that this is the inverse trig. So this is where you need to do the a and the u and the du. Okay, so what would a equal? 3. U is going to equal x, because that's just x squared, and then du is going to be dx. Okay, I want you to try to finish this blue part on your own. And definitely use the formula. Don't forget the 2, though. Okay, so hopefully this is what you got. Any questions on that? Did we get it? I mean, once you do this substitution, this whole thing right here equals arc sine of u over a. So then you just got to go back and see what was u over a. Okay, so then my final answer, and watch what I'm going to do here with the c. I'm only going to write it one time. I don't need to write it 2 times. You could write it 2 times, but you don't need to. Okay, turn the page. You guys thought we were done, didn't you? Psych. All right, look at this problem. Now I want you to tell me, what have we been doing every time the numerator's degree is larger than the denominator's degree? We've done long division. Yay! So I'm going to do this problem again, but I'm going to go through it pretty fast, but I want you guys to ask me questions if you don't understand this. Because by now you should, and we got to really fine-tune this. Because it just pops up, and you really don't get any partial credit for the long division. It's just an assumed part of the problem that you're able to do. Notice that I put in 0x's and 0x squareds. So I start with the dividing. X squared goes into 3x cubed, 3x times. And then we multiply, right? 3x times x squared, 3x cubed, 3x times 0x, 0x squared, 3x times 4, 12x. What's the next step? Subtract. And the way I subtract is I just change all the signs. First column always cancels. If you're lucky, another column cancels. That's going to mean less work. So then I have a negative 12x, and then I bring down a negative 2, and this is what we call our remainder. So the way this problem is rewritten is 3x plus my remainder over my denominator. Okay, on the quiz that we had on natural log, a lot of you did this and then you stopped. You were like, I did it, I'm done. We still have to integrate. And I'm actually going to continue this the way I did the last one because this numerator is still kind of messy. So I'm going to split this up even further and I want you to watch what happens. I'm going to just put the 3x like as its own integral. Okay, and then I'm going to split these two things into their own integrals just to make it super clear that we're really splitting this into 3 mini problems instead of doing one gigantic problem. So there's 3 different things we have to integrate. And then at the end, we'll put them all together. Which one is the easiest to integrate? The 3x. What is that? 3 times 1/2 x squared, right? You add 1 to the power of x, you put the reciprocal in front. That's how you integrate 3x. Okay, for the other ones, I'm going to kind of color code this a little bit. We'll do the second one in blue. Okay, this negative 12. What can we do to this? Move it to the front. So I'm going to ignore it. Now there's an x over x squared plus 4. Is this old U-substitution or is this inverse trig? If there's an x on top. Remember the inverse trig is like just u prime or du on top. Okay, so here's the thing. If you're not sure, you try it and you say, hey, that was wrong, and you try something else. Okay, this is the old kind of U-substitution. Watch what I'm going to do here. This is going to be, u is going to be the denominator. Then du, what would du equal? 2x dx. The 2 gets moved out. So far I have a negative 12 moved out, and I have a 1/2 moved out. And see how there's an x dx here and an x dx here, and it matches up perfectly? That's what you want to have happen. If that doesn't happen, then you did the problem wrong, and you kind of have to start over. And the more you practice this, the more you're going to know which one to do. It's not magic. It doesn't magically happen. You have to put in the time. So we get 1 over u du. So that's negative 6 natural log of u, or negative 6 natural log of x squared plus 4. Okay. I know this is a crazy monster problem. Hang in here with me. All right. So then we look at this last problem. The negative 2, moving it out to the front, leaving a 1. This is how I know this is an arctan problem. there's a 1 on top, and then there's an easy, it doesn't matter that if you think these are in reverse order, that's okay. With plus, it doesn't matter which order you add or subtract. So my a here is going to be, my a squared is 4, so a is 2. U squared is x squared, so u is x. And du is dx. So the negative 2 got moved to the front. And when we do the substitution, this 1 in dx gets replaced with du. And on the bottom, you have a squared plus u squared. You could have written that as u squared plus a squared. And that, as a formula, equals, I'm going to go ahead and write it over here, 1 over a arctan u over a. Plus c. Yeah, we're going to put a plus c at the very end. So I'm going to write negative 2 times, okay, 1 over a. That's 1 over 2 arctan of x over 2. And I'm going to cancel that. And so my final answer is going to be, I'm going to write this as 3/2. You don't have to. 3/2 x squared minus 6 natural log of x squared plus 4 minus arctan of x over 2. I know this is a lot, and I know some of you are feeling really overwhelmed because you were already behind today. You had things you didn't understand. So adding on new things is very overwhelming. So take this weekend to get caught up. Okay? You're only helping yourself out. Okay, last problem is actually considerably easier than the one we just did. Y'all ready?
Yeah. We're ready to rock.
Okay, I know this is probably an inverse trig because I see here I have a number squared plus like a function of x squared in the denominator. That's how I know this is probably inverse trig. And if this whole thing doesn't work out, then I'll have to try something else. So a, remember, is the number squared. So here a is 1. What's u, though? Sine. Some of you look at trig and you freeze. You actually don't have to do any trig in this problem, like computations or anything. All right, du then would be cosine x dx, which is right here. It works out perfectly. Okay, so the 3 gets moved to the front, of course. And the cosine x dx gets replaced with du. And the bottom is a squared plus u squared. Okay, I want you to see if you can write the final answer on this one by yourself. You can do it. Just look at the formula and follow the formula. There's the formula in case you were wondering. Okay, how's it looking?
Great.
Class.